Section 1, Video 7, Examples Part 3. Now with radicals, things get a little interesting. But the key is, can you rewrite something from radical form to exponential form? So we have to remember that we can write this as x squared to the 1/2 power. And again, even though we don't write a 2 in there, a square root does have a 2 inside there. And what that allows us to do is to take a power to a power, and we get 2 times 1/2 is 2 over 1 times 1/2, and it's top times top, bottom times bottom, which is 2 over 2, or just 1. Now again, the ability to go from radical notation to fractional exponents is the rule and the piece to this lesson we're trying to make sure we understand. Where you go from there in terms of how far you simplify is up to you lots of the time. So let's look at this next one. I can do this question first by saying 16x to the 4th all to the 1/3 power. Where I go from here to simplify, it's a matter of choice. I'm going to show you an older method that was used to simplify these questions and probably more familiar to you. I can write this as 2 to the 4th, x to the 4th in its prime factors. And what that does is it tells me that I have 4 2's and 4 x's. And if you remember, if it's cube root, you need 3 things to be able to pull out of a cube root. And when you do so, you get a 2 and an x, and what's left inside is a 2 and an x. Those are the things left over. Now with fractional exponents, a little bit more interesting. You're going to be asked to have a little bit better mastery level on this in Algebra 2 Trig, but we're going to go over the idea of what's possible here very quickly though. To do this one, we want to rewrite 16 as 2 to the 4th, which we rewrote earlier, to help us do the next step. We would distribute, and we would get 2, and again 4 times 1/3, 4 over 1 times 1/3 is 4/3. Same with x. I'm going to rewrite that as a mixed fraction, which is 4/3 is 1 and 1/3. I'm going to do that for both terms. Then I'm going to rewrite them as 2 to the 1, 2 to the 1/3, separate pieces. And I can do this because when bases are the same, you add exponents. And 1 and 1/3 is the same as 1 plus 1/3. Now notice that I have a 2 to the 1 and an x to the 1. And I have a 2 to the 1/3 and an x to the 1/3. And here's where we can just go ahead and put it back into radical notation. Same answer, but a much different way of getting to that answer. And it does not matter which method you choose, as long as you understand it. And that you can take this statement and write it in fractional exponents. If you can do, make sure you know how to do that much at least. Simplifying it would be your choice. Next one, same scenario, but we have 2 more things going on. We have 27 x cubed, or x to the 6th, being raised to the 1/3 power, and all of that is being squared. There's a couple different ways to go about this one. I'm going to show you one possibility. Here we have an exponent raised to an exponent. 1/3 times 2 is 2/3. Next one we have 27. Let's rewrite that in prime factors. So it's 3 cubed x to the 6th to 2/3. Now if you distribute that, you get 3 to the 6/3, x to the 12/3, and that reduces to 3 squared. 6 divided by 3 is 2, and x to the 4th. which is the same as 9x to the fourth. Again, pretty interesting way of doing things, but it is an alternative way and allows us to go further with a lot of questions that before in the past we had to stop because we didn't know how to simplify radicals any further. So it's a very valuable ability to take a radical notation problem and change it to fractional exponents. And this ends Section 1, Video 7.